Okay, people, I'm really excited to be here today. So we're going to be talking about solving quadratics. Today specifically will be about by the square root method. It's this really unique, fun method, and I'm really excited to teach you with it. So first thing you should know is there are multiple methods to solve a quadratic. What do I mean by solving a quadratic? Anytime you're solving a quadratic, you're looking for the roots is one way to say it. Solutions is another way to say it. Zeros is another way to say it. And x-intercepts is the last way to say it and probably the most important. When you're solving quadratics, you are looking for the x-intercepts. That's what you're doing. So the easiest way, and granted, people will say roots, they'll say solutions, they'll say zeros, they'll say find the roots of the quadratic, find the solutions of the quadratic, what they're talking about is the x-intercepts. It's exactly what they're talking about. So that's what you're doing when you're solving quadratics, you're looking for their x-intercepts. Remember, quadratics are U-shaped graphs. Parabolas are what they're called, and they can be facing opening up or opening down. The a value is negative. The easiest way is graphing it. Why? Because it's so visual. It's so easy. If I graph a quadratic, and look, right here, these are the two x-intercepts. So I can say the answers, the roots, the solutions, the zeros of this quadratic are -1 and 3. Bada bing, bada boom. This one has two answers, this quadratic. This guy just has one answer. He only hits the x-axis one time. So x equals 4 is the only answer here. And this guy, he never hits the x-axis. Because remember, this is the x, this is the y. He never hits it. So there are no real solutions here. So, solutions. There's no real solutions. So graphing is the easiest method because you can just physically see what the answers are. And we'll get into the fundamental theorem of algebra and why these things are really important later. But for right now, you can say, okay, we're going to solve by the square root method. Now this method, so I've just shown you graphing, which is visually what you're looking for. Now let me show you something else, solve by the square root. This is when there's no middle term. What do I mean by the middle term or the linear term? Remember how this is standard form of a quadratic? Remember? Ax squared plus bx plus c. If there is no middle term, you can use the square root method every time. So it's really interesting. It's just this unique case that I wanted to show you and hit because it's pretty cool. So down here, example 1. I wrote the f of x on the right hand side here just to, I don't know, show you it could be written like that or it could be written f of x equals. Doesn't matter. Sometimes it's written one way, sometimes it's not. Now, see how there's no middle term. Usually it's x squared minus 4x minus 16 or x squared plus 2x minus 16 or something. There's usually a middle x term. There is no middle x term. So I know I can use solve by square root. So when you're looking for x-intercepts, when you're looking for root solutions and zeros, that is when y is negative. Because think about it. Every x-intercept, this could be 2, 0. This could be -1, 0. Over here, it could be 10, 0. You know, way over here, it could be -50, 0. And every single x-intercept has a 0 in for the y. Every single one. So if I put 0 in for the y and then I solve, bada bing, bada boom. Isn't this guy really y? So I put 0 in right there. Equals 0. Bada bing, bada boom. Now, this is the next step. You always set quadratics to 0. Always. Always, always, always. The quicker you learn that, the better your life will be. Now, I get this x squared guy alone. How do I get him alone? I'd have to add over that 16, right? I need to get that 16 by itself, or this x squared by itself. So now I just have x squared equals 16, right? Because these cancel, 16's over here. Now the opposite of x squared, we've talked about this before, is if you square root it. The square root cancels the square. Just like adding 16 and minusing 16 cancel each other out. Square rooting cancels the square. What you do to one side, you got to do to the other. So now you just have x equals Now, you'd be thinking maybe the square root of 16 is just 4, right? But think again. Anytime you use the square root method, anytime you put one of these into the problem, you need to add plus or minus. Pause the video and think about why I would have to add plus and minus in front of that 4. Hopefully, you figured out that plus 4 times plus 4 equals 16, and minus 4 times minus 4 also equals 16. When you take the square root of something, it's something times itself that equals that number. So, x times x will equal x squared. That's why we can take the square root of x squared and it just equal x. 4 times 4 equals 16. That's why when we take the square root of 16, it equals 4. Okay? So, and negative 4 times negative 4 also equals 16. So we have to put plus or minus. If you choose to put the square root in the problem, you have to add plus or minus. Okay? So that is really your answer there. I'm actually going to scoot down to example. This should be 4. Good grief. Scoot down to example 4 here, because this one's a little bit easier. So first step, always set it to 0. Always set the quadratic to 0. Okay? It's missing the middle term, so we know that we can use the square root method. We want to get x squared alone. That's the first step. So I'm going to add 64 to both sides. So now I have 64 equals x squared. Right? We got them alone. We got the x squared alone. Beautiful. What do I mean by that? There's nothing being added or multiplied, subtracted, divided, anything from this x squared. He's alone. Now we got the x squared alone. We can take the square root of both sides. The square root of x squared is just x. The square root of 64 is 8, but we have to put plus or minus in the front because minus 8 times minus 8 also equals 64. So plus 8 and minus 8 are the two answers. Plus 8, and minus 8 are the two answers for this quadratic. And if you want to see something else, just for you visual people, just to get this rolling, if I graph this, x squared minus 64, graph, hits at minus 8 and plus 8. That's what we're figuring out, that when we graph it, that's what we're finding are the x-intercepts. This is just a trick way to do it algebraically. All right, let's go back up to example 2. We're going to crush this guy. First step, always set it to 0. Okay? Next step, we get this x squared alone. So there's a 2 being multiplied and a 50 being subtracted. We should deal with the 50 first. If we divide the 2 first, we have to divide each piece by 2, which is fine. It just makes things a little bit more complicated. So we got to get that x squared alone. I'm going to deal with the 50 first. Now I have 50 equals 2x squared, right? Because these cancel each other out. 50's over there. Still got the get the x squared alone. So we need to divide by 2. Those will cancel. 25 equals x squared. We got the x squared alone. Now we can use the square root method. Square root of x squared. Bye. Bye, drama. Bye. They cancel out. You just have x. Hold on. It's so hard to write when I can't. My one hand. Square root of the x squared just goes to x. Square root of 25 goes to 5. We got to add plus or minus in it. Okay? And then, for you visual people like me who loves to see math visually, because I get it, people. 2x squared minus 50. If I go up here and graph it, because f of x equals y, that's why this is the same problem. Graph, it will cross at minus 5 plus 5. Bada bing, bada boom. And furthermore, when we go to the table, there is a 0 in for the y, which is the x-intercept. And also a 0 in, oh wait, we need to be on the other side, sorry. Negative 5, there's a 0 for the y, because it's an x-intercept. It's an x-intercept. It's a 0, it's a solution, it's a root. Now, what the heck does this 0 in the x mean? Pause the video and tell me what you think this means to yourself, I guess. You can't tell me right now, I'm not there. Piece of hair on my calculator. This means it's the y-intercept. If you have 0 in for x, it's the y-intercept. 0 in for the y, it's the x-intercept. Say it one more time. 0 in for the x is the y-intercept. That means 0, negative 50 is where this graph hits the y-intercept. 0 in for the y is where the x-intercepts are. Okay, people, last problem. Every time we set quadratics equal to 0, always, always. Okay. Then we got to get the x squared alone. So I'm going to deal with that 27 first. Switch colors for my ADHD. We have 3x squared equals 27. We added them over, bada bing, bada boom. We still need to get this x squared alone though. So we're going to need to divide by 3, divide by 3. That will cancel those out. 3 over 3 just algebraically goes to 1. So we have x squared equals 27 divided by 3, 9. Human calculator. So pumped. Now we have the x squared alone. We can use the square root method now that we have it alone. So square root both sides. Square root of x squared, x, square root of 9, 3. Got to add the plus and minus in front of it if we choose to put the square root in the problem. So the two answers are x equals 3 and x equals -3. Those are the two places that it would cross the x-axis. Those are the roots, those are the solutions, those are the zeros of that quadratic. So really quick recap. You can solve quadratics with a bunch of ways. Today we did the square root method, which is when there's no middle term. There was no middle term on any of these. Graphing is the easiest because you can visually see it, where they cross the x-axis, which is the answers, the zeros, the root solutions that we're looking for when we solve quadratics. And you always have to get the x squared alone, then you can use the square root method and square root both sides. Make sure you always put the plus and minus in front. Woo! Bada bing, bada boom. Good luck, people.